Hello and welcome to Vision Extra, come to you from Vision Australia Radio. Peter Greco with you. And we're very pleased to welcome to the program Dr. Karl Brown from the Centre for Eye Research. Karl, if I may call you that, so thank you so much for your time.
Thank you.
Now, you're going to talk to us about some of the research you're doing in corneal research, but before that, maybe you could explain a little bit about what the cornea is and what sort of a role it plays as far as sight and eye conditions go.
Okay, so just to get everyone oriented, the cornea is the clear window at the front of the eye, and it has a role in, well, lets the light in because it's clear, but it also bends the light and contributes towards focusing so you can get a clear picture. The cornea has 3 layers. So if you imagine like a nice sponge cake, the top layer is the corneal epithelium, then there's a middle spongy layer called the stroma, and then that very, very thin, sort of darker brown, a crust at the bottom, if you like, of your sponge cake. That kind of corresponds to the endothelium.
And what sort of things can go wrong, or what sort of role does it play, maybe first of all, and then what sort of things can go wrong? Yeah,
so because the cornea is, like I said, the window at the front of the eye, if the cornea becomes damaged and loses its transparency, then obviously you can't see because no light can get to the retina. So with corneal disease, that can be from scarring, it can be from infections, it can be from inherited disorders, and all 3 layers of the cornea that I described earlier, the epithelium on the outer surface, the middle stroma, and the endothelium can be affected by different diseases.
Okay.
Yeah.
And they can all be affected differently at different times. So if one layer, for example, is diseased, it doesn't mean the other 2 are, or vice versa?
Exactly, exactly. And that's kind of really important for how surgeons have been looking at treating corneal disease recently. So traditionally you'd have a full thickness cornea transplant, which means they replace all 3 layers with donor cornea. But recently surgeons have looked at doing what they call laminar transplants. So they just replace the layers that are diseased, and when that happens, that restores sight.
Okay, is that a good thing? I mean, maybe what are the benefits of doing just the damaged layers rather than the whole 3 at once?
In a lot of cases, it reduces the chance that the donor cornea will be rejected eventually.
Oh.
It also gives better visual outcomes in a lot of cases because there's, less stitches and less cutting involved. So there are a lot of benefits to doing these so-called lamellar transplants.
Okay, so in a sense, it's sort of refining or sort of even honing down even more to a exact degree what's wrong and fixing that little problem rather than sort of fixing a big problem or trying to fix a big problem, with a big transplant. And of course, rejection is one of the things that can affect transplants adversely if it happens.
Yeah, it's actually one of the leading causes why cornea transplants fail is rejection still.
So, Karl, would most people have heard of some of the corneal diseases that can affect people? I mean, we've over the time enjoyed our chats with people from the Centre for Eye Research and heard about the different diseases. Would most people know a corneal disease by its sort of generic name or more, less medical name?
I think a lot of the corneal disease that we see is either from trauma, so just an injury really, but there's also infections, so bacterial or fungal infections that get into the cornea sometimes because it is, the outermost layer of the eye. And there are other diseases of the cornea like bullous keratopathy that come with aging, and also diseases like Fuchs dystrophy, which have a genetic component.
Okay. What about as far as diagnosing conditions go? Is it fairly easy because, it's easy to see from the other side's point of view, from the surgeon or the ophthalmologist's point of view?
Yeah, so the cornea, because it is, when it's healthy, it's a clear window, and it is on the outer surface of the eye. It's, the surgeons can see and diagnose disease largely by observation and by doing what they call a slit lamp, which enables them to sort of look at all three layers with a little magnification and other techniques.
Yeah, I'm sure many of our listeners would have heard of those particular machines, the slit lamp. So
Yeah.
tell us about your research then. What are you doing, and what sort of impact do you hope this is going to make?
So what we are tackling is looking at replacing, for some patients, that donor tissue that can reject, or in many countries is in short supply. So because of those lamellar transplants where you're just replacing the broken layer, we can look at growing the individual layers of the cornea in the laboratory. And if we can get one of those to work, then that will benefit a lot of patients, and we go from there. So
Okay.
Our current work is with the corneal endothelium, that very inner layer.
So that's just one layer. So you're literally taking it to one layer at a time.
Yes, yes. And then eventually in the future, if we get all three layers, then we could build it up and create a full thickness one as well. But at the moment, most of our work is focused on the corneal endothelium, which accounts for about 60 to 50% of cornea transplant cases in Australia and the United States, for example.
Okay, well, it's certainly the majority, isn't it? If you got 50 or 60% out of 1 out of 3 of them, that's obviously covering a big percentage. Is one of the advantages of the work that you're doing, if it comes off, is less chance of rejection?
That could be the case. We know that, for example, when you just replace the corneal endothelium with donor tissue, the rejection rate is much lower. If we were able to, say, grow a laboratory-grown transplant from the patient's own cells or using stem cells, that rejection rate could be lower still. We would expect it to be at least as good as doing one of these lamellar transplants. And if we use the patient's own cells, which might be an opportunity to reduce the rejection rate to 0.
And then, of course, the advantage is that if you're producing them in the laboratory, then in a sense you can produce as many as you need. Because I'm assuming that for someone to have a corneal transplant, you know, someone's got to be a donor, so therefore someone's got to die.
Yeah, that's the unfortunate truth of the matter. But also, you know, that donor tissue has to be collected and has to be stored. There's a great deal of organisation and community awareness that needs to happen for that for a cornea to become available for transplantation. And so this means that in most of the countries in the world, something like 50 to 70% of the world population has no access to donor corneas because donation does not occur in their nations, or there's not enough. And so if we could get this running, and particularly if we could harness the power of stem cells to mass produce corneal endothelium, then we could treat a lot of people who currently have no opportunity to regain their sight.
So you talked about people maybe donating their own tissue. What else is a possibility as far as, if you like, manufacturing this layer?
Yeah, so donating your own tissue obviously would mean that there'd be no rejection, but that's in many ways a limited and almost boutique solution. Another solution would be to use induced pluripotent stem cells, perhaps made from skin cells or other cells of the body. There are many existing cell lines that are induced pluripotent stem cells. And then using those, you can produce essentially what is an unlimited amount of corneal endothelial cells that could then be used with our technology for transplantation.
So if you're using stem cells via the skin, is that again from the person with the condition that you're going to eventually put the layer back into?
So it could be, or we could do what other countries are looking at, which is produce for other organs, which is producing banks of stem cells that are very good matches for most of the population.
Karl, one of the things I've learned chatting to people such as yourself and others, of course, is, you know, we can get very excited when breakthroughs take place. And of course, in the reality of life, it takes a long time for this to come to fruition. So where is your research at, and how far away might your dream be?
So we have very good experimental data for doing the growing from cells taken from a cornea and then growing that on our special plastic that we use to deliver the cells. We are now looking at moving into induced pluripotent stem cells, and that'll be the focus of my work for the next year or two. However, I think a lot of the barriers to progressing this work are purely financial, in that it's very difficult to get sufficient money to do a first-in-human trial, and companies are very reticent to invest in technology until that first-in-human trial has reduced most of the risk for them.
Yeah, and I guess that's despite the the possibilities that something like this might have. The blue sky is there, but I guess, as you say, people are going to come up with the financial support first of all before it can progress to maybe, if you like, reaping dividends down the track.
Yeah, exactly. And it is a known problem in medical research that there's this so-called valley of death between the laboratory bench and produce commercial quantities that can treat many patients.
Yeah. Karl, just a question without notice, and if you don't want to answer, I totally understand. Given what's going on at the world with the coronavirus, is maybe getting research funding even tougher now? Everyone is maybe, well, not everyone, but a lot of people are putting funding into finding this elusive vaccine.
I can think of at least one funding program that has announced that it is going to prioritize COVID-19. I think that it will have some effect. What that effect is and how much, what proportion of funding will go that way, I don't know. Having said that, obviously, given the severity of the crisis we face at the moment, I don't begrudge anybody who receives COVID-19 funding at this point in time.
I guess, like everyone, we're all battling for a vaccine quickly. And from a research point of view, once that's done, then people can get back to getting funding for the research that they're doing. So it's literally a win-win situation if that vaccine does arise quickly.
Yes, let's keep our fingers crossed.
Karl, great to talk to you. Fascinating stuff. It'll be good, as I often say, to keep in touch with this as it rolls out. It sounds very, very exciting. You've explained things very, very well. So really appreciate that. Thank you for your time, and we wish you well.
Thank you.
That's Dr. Karl Brown from the Centre for Eye Research doing corneal research. Very, very interesting, and we'll certainly keep in touch with Karl about that. That is it for the program. If you've missed some of it, maybe you'd like to hear it again, you can go to our website, www.varadio.org/podcast. This program is Vision Extra. We'll be back on this radio station at the same time next week.